This project encompasses the use of high-accuracy yet inexpensive sensors for data acquisition in physics experiments and the Raspberry Pi. The open-source software package PhyPiDAQ, developed by the Professor Quast at KIT in Germany, manages the recording, real-time displaying and saving of data. The first experiment is charging and discharging of an electrolytic capacitor over an ohmic resistor. The voltage across the capacitor is converted into digital signal with an analog to digital converter. In the PhyPiDAQ configuration, one can use formulae for displaying directly the amount of charge stored on the capacitor. In a second experiment, a time-varying voltage with a square form is generated at the 2 pins of the Raspberry Pi by a light-dependent resistor-operated switch with an application programmed in Python which runs in the background. All experimental settings allow quick acquisition of large amount of quality measurements saved in CSV files, which can be used in many interdisciplinary ways, like for instance in maths or for other relevant physical contents. In the next experiment, students carry out accurate measurements of physical quantities in DC circuits like current, voltage, and power with the ENA219 sensor. All the significant features of the current voltage characteristic of a light-emitting diode are analyzed and clarified within various physical and mathematical contexts. An experimental circuit based on an analog-digital converter displays the current voltage characteristic of 3 different LEDs at the same time. The measured quantities can be saved and analyzed with a spreadsheet program to determine the activation voltage of the LEDs with a goal to calculate the Planck's constant. In this experiment, students analyzed the harmonic oscillation of a spring pendulum with 2 sensors at the same time. The elongation is recorded with a distance sensor which uses time-of-flight measurement of infrared pulses. An analog sensor for measuring forces is interfaced with the Raspberry Pi via analog to digital converter. Faraday's law of induction is experimentally proved by generating a voltage surge in a static coil with a moving permanent magnet. The induced voltage as function of time is recorded with the ENA219 sensor. Students observe the value and polarity of the induced voltage and current when the magnet is inserted in and withdrawn from the coil. Lastly, the readers can find more information about the integration of Raspberry Pi-based measurement system into the STEM concept, as well as about the advantages of experimenting in integrated multidisciplinary instruction.